Hello and welcome to this video on writing a rational expression equivalent to a given rational expression. So here in this video I'm going to do a couple examples where we're given a fraction, right, a rational expression with a polynomial in the numerator, polynomial in the denominator, and going to rewrite it as an equivalent fraction, an equivalent rational expression with a given denominator. All right. So we'll see that here. My first example, here I'm asked to write the rational expression as an equivalent rational expression. So a fraction that is equivalent has that takes on the same values for, no matter what I plug in for the variable with the given denominator. So I have 2x plus 1 divided by x minus 1, right, a rational expression, a fraction. And I'm trying to write another fraction that's equivalent to this, but with this denominator instead, right? Instead of just x minus 1 as the denominator, I would like the denominator to be x minus 1 times x plus 3. Alright, so a little bit of a side note here. I'll do an example like I've done in previous videos where, we got some variables over here, some letters, but do an example of, doing the same thing with some numbers. Alright, so say I asked to write the fraction, 2/5, say with a denominator of 20 instead. Alright, so we're going to write 2/5 as a fraction that's equal to it, right? That means has the same value as 2/5, but with a denominator of 20 instead. So I take my 2/5, right, and I would like to change the denominator to 20. Well, in order to do that, I would multiply 5 by 4, right? Now you can't just multiply the denominator by 4, because if you did that, you'd have 2 in the numerator and then 20 in the denominator, and 2/5 is 0.4. 2/20 is not the same as 0.4. 2/20 is actually the same as 1/10 or 0.1. So you'd get 0.4, 0.1, not the same thing. So you can't just multiply the denominator by 4. I also have to multiply the numerator by 4. Now the reason for that is so that it's exactly like we're multiplying by 1, right? 4 divided by 4 is 1, right? Anything divided by itself is 1. And when you multiply by 1, you don't change the value of your number. Okay, and then in fraction multiplication, you just simply multiply the numerators, right? 2 times 4 is 8 over, and then the denominator 5 times 4 is 20. Okay, so what we have here, what we're saying here is that 2/5 is equivalent to 8/20. Right? Both of these are 0.4 if you wrote them in decimal form, but they do represent the same number. And remember, another way to check if two fractions are equal are multiply their their cross product, take their cross products. Is 2 times 20 equal to 8 times 5? Right? 2 times 20 is 40. 8 times 5 is 40. These are equivalent fractions. Alright, and in general, when you want to change the denominator of a fraction, you just do exactly what I did here. You multiply the numerator and denominator by the same expression. So in general, if I have a fraction, say a over b, and I wish to change the denominator to something, I'm going to multiply the denominator by some other expression. Again, I'll call it c. And whatever you do to the denominator, you must also multiply the numerator by, so that way it's like I'm multiplying by 1. And we get a totally new fraction with a new denominator, right? A times c over b times c. that's equivalent to a over b. And one other thing I want to point out down here is that remember denominators can never be 0. So throughout this process, the denominator b cannot be 0, and the c that I multiply by in the numerator and denominator, that can't be 0 either. Right, so b can't be 0, c can't be 0. And if these are not 0, then b times c is not going to be 0. Right, the product of two non-zero numbers is going to be non-zero. Okay, so let's keep that in mind. I'm going to point that out to myself as well as we go through these examples with variables. Alright, so my problem here again was, take this fraction 2x plus 1 over x minus 1, and I'm going to rewrite it as an equivalent fraction with this denominator instead. So the x, notice the x minus 1 is there. I'm just missing this factor of x plus 3. Okay, so I've got 2x plus 1 over x minus 1, and again what I want to do is multiply the I have x minus 1 as a factor already in the denominator, but I would like this x plus 3, so I'll multiply the denominator. Now notice the denominator has multiple terms, so I'm going to put it in parentheses, right? We're multiplying not just one of these terms but the whole thing by this factor of x plus 3. And again, it's got multiple terms, so I'm putting it in parentheses, and we're multiplying by this whole thing, all these terms. And then, I can't just multiply the denominator by x minus x plus 3. I also have to do it to the numerator. And again, the numerator has multiple terms, so this 2x plus 1 I'm going to put in parentheses, right? You're not just multiplying the 2x, you're not just multiplying by the 1, you're multiplying by the whole thing. And I multiply the numerator also by x plus 3. Right. And then we finally have our new equivalent fraction. Right. So the final result here, I've got the product of 2x plus 1 times x plus 3 is the new numerator, over, and then the new denominator is this product of the quantity x minus 1 and x plus 3. Okay, and this is great, right? This fraction here is equal to this fraction here, but with a new denominator, with the denominator that was specified. But not all the time, right? These fractions are equal only when they're defined, only when the denominator is not 0. So I would like to now also put the values that I cannot replace x with. Alright, so this fraction is equal to this fraction as long as x is not 1, right? That'll make 1 minus 1 will make my denominator 0. So as long as x is not 1, and also as long as x is not negative 3, right? Because now I have this factor of x plus 3 in the denominators. And if x were negative 3, you'd be multiplying here by 0 over 0, and 0 divided by 0 is undefined. Anything divided by 0 is undefined, so negative 3. So, but now check it out, right? Try it out. As long as x is not one of these, this is a good answer. All right, so let me test this. All right, and let's try a number. So I'm going to try to plug in here again just any value of x you wish, as long as it's not these two, as long as it's not 1 or negative 3. How about this simple one would be, what if x were 0? If x were 0, let's go to this original fraction, right? 2 times 0 plus 1. The numerator would be 1. The denominator would be 0 minus 1, negative 1, and 1 divided by negative 1 is negative 1. Okay, so the value of this fraction is simply negative 1 when x is 0. And the value of this fraction is, you got, again, 1 times 3 in the numerator, and then negative 1 times 3 in the denominator, and hopefully you can see that this is just 3 divided by negative 3, which is again negative 1. Alright, So yes, they are the same when x is 0, this fraction and this fraction. And test any other number out you want. Right? Plug in 5, a billion, a third, a fifth, -5, whatever you want, as long as it's not these two. And this fraction should be equivalent to this fraction because this x plus 3 will cancel as long as these are not 0. Right? And again, that factor can't be 0 either in the denominator. All right. So I've got only one more example here. In this first example, notice my denominator here was already kind of not factorable. X minus 1 is like as factored as you can get, but in most problems that we're going to come across, it would be nice to factor your denominator first. And I'll put that little note off to the side here on this page for this example. When I'm trying to write one fraction as an equivalent fraction with a new denominator, I think it would be easy to first factor the denominator I have, right? Factor my original denominator. So I'll factor the denominator completely first. Right, that'll be the first step I do. So here I'm writing the fraction 3 over, the denominator is 4p squared minus 8p. And I want to write it as an equivalent fraction with this denominator instead. 16 times p cubed, that's a 3. Sorry, it's a crappy 3. 16 times p cubed times the quantity p minus 2. Alright, so let's take our 3 over 4p squared minus 8p, and again I'm gonna factor the denominator first. So the numerator is still 3, and the denominator has multiple terms. In the last example it was just x minus 1, so nothing really to factor out there. The greatest common factor was 1. Here 4p squared and negative 8p, these have a greatest common factor of 4p. And if you'd like to factor 4 out further, 4 is 2 times 2. But I'll pull out 4p, right? Again, you can write that as 2 times 2 or 2 squared times p. So there's the greatest common factor pulled out. And then when that factor is removed, what's left over would be p, right? 4p times p is 4p squared minus 2. Right, 4p times 2, negative 2 would be negative 8p. Alright, so now the denominator is factored completely, right? You can't, again, you could break down 4 to 2 times 2, but usually just numerical factors are fine the way they are. If I was simplifying the fraction, trying to simplify, maybe I'd factor that to 2 times 2, but for right now we're just changing the denominator, right? Not simplifying. So I'll keep that as 4 times p minus 2, and p minus 2 can't be broken down any further, so this denominator is factored completely. Now comes the part where I multiply by 1, right? Where I multiply the numerator and denominator by the same number, okay, by the same expression. Alright, so I'm going to multiply it. Now I want to do it so that this denominator becomes this one that was given to me. Alright. So look at that. I've got 4 as the numerical factor here. 16 is the numerical factor of this denominator that I want. Let's see, 4 times what is 16? 4 times 4 would be 16, right? So I'd have to multiply by another factor of 4 to give me 16. There's p to the first here. This is p to the third. So there's only one factor of p in this denominator. I would like 3 factors of p. So that means I need 2 more. So 4 times p, or you could say 4 times p squared. Right? 2 more factors of p. And then the p minus 2 is already to the first power in both of them, so I don't need to multiply by anything else. Right? There's already that p minus 2. So really all I'm multiplying by here is what's missing to get me this denominator here. What's missing from this denominator that would give me that denominator? Alright, so if I multiply that, again, if I multiply the denominator by 4p squared, I also have to multiply the numerator by 4p squared, right? So that way it's like you're multiplying by 1, right? Anything divided by itself, any non-zero, and make sure these are not 0, right? Any non-zero number divided by itself is 1. Alright, and then in doing this, we'd get our final result. Just again multiply the numerators. 3 times 4p squared would be 12p squared in the numerator, divided by, and then we get the denominator we wished for, right? You got 4p times p minus 2 times 4p squared. I got 2 factors of 4. 4 times 4 is 16. Got a factor of p here, 2 factors of p here, so that's p cubed. 3 factors of p to the third. And then I got this factor of p minus 2, right? So times p minus 2. And this is great. This fraction right here is equivalent to the fraction I started with, but with this new denominator. But again, not always, right? The only time it's not going to be equal is when they're undefined, when you are dividing by 0. So off to the side here, I'm going to put the values I cannot plug in for p. All right. So again, just make sure you never have 0 in a denominator. Well, if you look at the factored form, it'll make it easy. All right. You have a factor of p, so that can't be 0, because if this was 0, the whole denominator would be 0. So p cannot be 0. Same thing over here, right? If p were 0, this denominator would be 0. You'd have 0 divided by 0, which makes no sense. So p can't be 0 because of the factors of p, but also you have this factor of p minus 2 showing up in the denominator. So that can't be 0 either, that factor. So the value of p can't be positive 2, right? 2 minus 2 is 0, and they'll make the whole denominator 0. And again, you can check these back in the original too. If p were 0, you'd have 0 minus 0, or 0 in the denominator. That's no good. And if p were 2, you'd have 16, 4 times 4, minus 8 times 2, 16 minus 16 is 0. So again, you can see however you want to see it, that p cannot be 0 and p cannot be the number 2. But anything else is fine. Alright, so again, I'll put this in a little box here. This is the final result I'm looking for. Alright, this fraction will be equal to this fraction as long as p is not replaced by these two numbers. And let's test it out. Alright, so off to the side here, I'm just going to try a value. Try a value of p. Again, that's not 0 or 2. How about 1? Alright, how about when p, again, you can plug in whatever you want that's not these two. Plug in a million, a billion, 10, 1,237, pi, the square root of 3, 1/5, negative 8, again, as long as it's not those two. Alright, so p equals 1. So back in the original fraction, the numerator is 3. The denominator would be 4 times 1, 1 squared is 1, minus 8 times 1, 4 minus 8, negative 4, so negative 3/4. Alright, negative 0.75, negative 3/4 would be the value of that first fraction. Alright, and then when p is 1, this fraction down here that we have, you have 12 times p squared. That'd be 12. 12, and when I replace p with 1, that'd be 12 times 1, so 12 for the numerator. And then 16 times 1, 1 cubed, and then 1 minus 2 times 1 minus 2. 1 minus 2 is negative 1, so 16 times 1 times negative 1, that'd be negative 16. So I'm getting negative 12 sixteenths. Is that equal to negative 3/4? Well, yeah. I mean, they do the cancellation, right? This would be negative. 12 is 3 times 4. 16 is 4 times 4. The 4s would cancel, and yes, indeed, that is equal to negative 3/4, right? They're both equal to negative 3/4 or negative 0.75, if you want to write in decimals. But this fraction is indeed equal to this fraction when the value of p is 1, and that'll work out no matter what you plug in for p. Right. Now the number they're equal to won't always be negative 3/4, right? Like if I put in if I put in 5 for p, right, the numerator would be 3, and then, this would be 100 minus 40, 3, it'd be 3 over 60, 1/20th, and then this would end up being 1/20th as well. But yeah, so just, they're equal, and they have different denominators, but that's okay. They are equivalent no matter what I plug in for p, except 0 and 2. Alright. So factor your denominator. If you're asked to rewrite a fraction as another fraction with a different denominator, but still equal to the original, factor your denominator completely, and then just multiply the numerator and denominator of it, by the same thing. So that way it's like you're multiplying by 1, and multiply the numerator and denominator by the factors that are missing. Right, like 4 and p squared were missing from this to make that, and x plus 3 was missing from this denominator to make this, and you should be golden. And always be careful to, off to the side somewhere, make sure you know that there are certain values of variables that you can't plug in, right? Make sure you're never dividing by 0. Never have a factor of 0 in a denominator anywhere. Okay, and that's it for this video today. And as always, I like to say, please try your best to learn the material on your own. Understand, get things on your own first, because I feel like things tend to stick better in your mind when you've done it on your own. So read through the material that you're provided. Read through the examples the author gives. Practice problems in the text or in whatever material you're given. Look for answers in backs of books or however they're provided. And just don't give up. Don't be too frustrated too soon. Don't give up after the first attempt. If after several attempts at a problem or an exercise you're still having trouble, even don't give up then. Try reading through the material again. Maybe even a third time, because who knows, maybe that second or third time you read through it, something will click. If you've been practicing, maybe you saw something in your practice that when you go back and read through the material, you'll be like, ah, I see it now. So maybe something will click the second or third read through that didn't click the first time. But if after that, if after several read-throughs of the material and several attempts at problems, you're still not getting it, something's still not clicking, then it is not a sign of weakness whatsoever to go asking for help. That is what other people are there for. So ask a teacher, ask a tutor, ask a friend in the class or just a friend who happens to know the material well. Go out looking for videos online. There's plenty of them out there. Look a video like this one, or plenty of others out there that are better, I assure you. And just keep at it. Stay persistent. Keep practicing, and I know you'll get it. I just know it. And also try to have some fun with it. Try not to bore yourself too much when you're doing this stuff, because that'll just make you lose it right away. So keep at it and have fun. Thank you for watching.